Hey guys, what's happening? So let's get warmed up here. First thing I need you guys to do is use the point -912, which will be on the terminal side of angle theta in standard position, and then find the 6 trig functions of theta. Okay, and then when you're done with that, see if you can do this one. Find the 6 trig functions of theta if it equals 540. Okay. All right, here we go. Hoping you paused it and you're not just going to copy from me. Here we go. All right, so the first thing we want is we want this point to be on the terminal side of the angle theta in standard position. So what I'm going to do really quick is just sketch this really quick. All right, so it says -9, 12. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's my point right here. And here is the radius, okay, of that circle that it's on, right? This is on a circle, right? It's on the unit circle going around, okay? And basically what we have here now, okay, is a triangle, okay? And the triangle is kind of hiding right here, okay? Notice it's a right triangle, okay? This side is 9, okay? And this side right here is 12, okay? And basically we want to find this guy right here. I'm sorry, this is, keep in mind this is -9, sorry, that's kind of confusing there, okay? All right, well, we're gonna actually find this angle right here. I know the angle theta would be right here, but we're going to be able to find all the 6 trig functions using that angle. Okay, so let's see what we could do here. We know that we need this missing side here, right? So I think this is a 3, 4, 5, isn't it? 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. So I'm guessing this is going to be 15. Okay. All right. So anyway, so we've got basically everything we need to know. If this is our theta, remember we're going to use SO, ka, toa. Okay. All right, and let's do this. So the sine of theta is equal to the opposite, right? I'll put an O, and I'll put an H, and I'll put A for adjacent, okay? So the sine of theta is going to be 12 over 15, which reduces to, what, 4 over 5? I'll just put 12 over 15. It's going to be easier to see that way, okay? All right, then we want the cosine of theta, okay? And that is adjacent over hypotenuse, so -9 over 15. So -9 over 15. And then we want the tangent of theta, okay? Which is opposite over adjacent, so 12 over -9. 12 over -9, okay? And this, again, it reduces to 4/5, okay? This right here reduces to -3/5. This right here reduces to what is that, 4/3, okay? All right, and then we have the cosecant of theta, which is going to be the reciprocal, so 5 over 4. Then we have the secant of theta, which is going to be -5 over 3. And then we have the cotangent of theta, which is going to be -3/4. Okay, so that's how that works. All right, and then we have this guy here. Find the 6 trig functions of theta when theta is 540. Okay, so now we get to use our unit circle because 540 appears on here. Do you know where it is? Well, let's go around. Here's 360. Okay, plus 90 more, right, is 450. Plus another 90 more is 540. So this guy right here is also 540, right? Okay. All right, and what are the coordinates right here? Well, it's -1, 0. And remember, this is your cosine and this is your sine. Okay, so let's do it. All right, let me see if I could squeeze both of this in here. All right, so my sine of theta is going to be 0. My cosine of theta is going to be -1, okay? the tangent of theta. Now remember, tangent is sine over cosine, okay? You remember that from your notes? We didn't really do much with it, but remember the tangent is going to be the sine over the cosine, okay? Which is 0 over negative 1. So 0 over negative 1, that equals 0, okay? All right, now let's do the reciprocals of this, right? So the cosecant of theta is going to be the reciprocal of 0. Well, that puts 0 in the denominator, doesn't it? Okay, so that we can't have that. So this is like 0 over 1, right? So if you write this as 1 over 0, that is undefined. Okay, and we'll just write UND for undefined. All right, and then the secant of theta is going to be the reciprocal of negative 1 over 1, which is still negative 1. And then we have the tangent of theta, the cotangent of theta, okay? And that's going to be the reciprocal of 0 again, right? The reciprocal of 0 puts 0 in the denominator, so that's also undefined, okay? All right, so that's how you're going to do those guys. All right. All righty. Now, maybe that wasn't much of a warm-up. Maybe I had to show you how to do everything. That's okay. You'll get more practice for your homework, okay? All right, let's move on to the bulk of this stuff. All right, oops, bonk that. Today we're going to be finding trig functions of basically any angle, okay? So we're going to, let me see if I can't. That's better. Okay. All right, so here we go, 13.3. We're going to find trig functions of any angle. Okay. And the first thing we're going to do is talk about reference angles. Okay. So let's do that. Reference angles. All right, now the book kind of goes one direction with this. I kind of go a different direction. And so we're not going to really be doing much with reference angles at this point. I think in the next section we will. There is a reason the book is showing you reference angles right now. But I've kind of got an easier way to do it. We use our unit circle. And if we're not using our unit circle, we're going to use our calculator. So we don't really have to deal with this too much. But what I'm going to do is show you what reference angles are. So here's my first example. My first angle is negative 150 degrees. Okay. So after you get the hang of this, you'll get quicker at it. But let me just show you this, okay? So the first thing we want to know is what quadrant this is in, okay? So negative 150 degrees, well, we go this way, right? All right, and right there is negative 150 degrees, okay? And that's in quadrant 3, okay? So it's kind of important to remember that. That's quadrant 3, okay? Well, really, all you have to do to find the reference angle is ask yourself, what's the distance? Okay, so we have 0 here, we have 180 here, okay? Basically, all you really need to do, don't look at the book. The book is gonna give you crazy stuff, equations and adding and subtracting. Just ask yourself, what is the distance right here, okay? What is the measure of that angle right there, okay? That's all you have to do, okay? So and don't even worry if that's negative, okay? Just tell me, what is the measure of that angle right there? Well, from 150 to 180, that's 30 degrees, okay? So my reference angle is 30 degrees, okay? That's really it, okay? It's easier with a picture, but you'll start to get the hang of it. Let's try another one. Let's try 320, okay? All right, so 320 degrees. All right, so I'm just gonna go ahead and draw. And don't worry, I put quadrant 3, it's just kind of mental notes. Okay, the reference angle is 30, that's basically what you need. The quadrant 3, just keep that up there in your noggin for now, okay? All right, so 320. So here we go. I'm going to go around the circle, right? It's all the way around to 360, but I'm going to stop short of 360. I'm only going 320 degrees, right? Okay, so 320 degrees is probably right about there. All right, so here's 320. Okay. And all you have to do to find that reference angle, first thing I want to just kind of make a mental note. This is in quadrant 4, okay? And all I'm doing is asking myself, what is the measure of this angle right here? Okay, what's the measure of that angle? Well, how many degrees do you have to go to get from here to 360? Okay, all right, well, it is 40 degrees. So my reference angle is 40, okay? 40 degrees. The reference angles are always going to be positive, okay? All right, let's do some radians. All right, how about I have -5 pi over 6, okay? Let's do -7 pi over 6. Let's do that instead, okay? Let's do -7 pi over 6. All right, I'm going to try to get something in the top half of the circle, okay? All right, well, here, let's go -1 pi over 6, 2 pi over 6, right? 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, right? Okay. So this is -7 pi over 6. Okay. And what's this guy right here? Isn't this 180 degrees? Okay, or isn't it just pi? Couldn't you also call it 6 pi over 6 if you really wanted to? Okay. All right, that's just pi. Now I know this is negative, okay? The only reason I'm even writing that is because I want to show you how I got there. The main thing is I kind of want to know that I'm in quadrant 2. Okay, that's quadrant 2 that it's in. Again, it's just a mental note for now. It'll come into play later, I promise, okay? But the reference angle, okay, my reference angle is, well, again, ask yourself, what is the distance right here? What is that measure? Well, to go from 7 pi over 6 to 6 pi over 6, right, what's the distance there? It's just 1 pi over 6, right? So pi over 6. Now, I don't know if you notice anything. You might not notice it yet, but let me just show you. When you're dealing with radians, it's really awesome because the reference angle will always be pi over whatever the denominator is, okay? You might not see it here, but watch. We'll do it on the next example, and you'll see that whatever my angle is that I'm giving you, the reference angle will always be pi over whatever the denominator is. Watch, here's another one. Okay, let's do this. 15 pi over 4, how about that? So we'll go 15 pi over 4. All right, and let me go ahead and just do a quick sketch. Okay, so here's 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 pi over 4. And if you're not sure how I'm doing that, stick around for office hours. I'll help you. Okay, here's 15 pi over 4. All right, we're trying to get all the way to this guy right here, okay, to 0. So just ask yourself, what's the distance right here, okay? Well, isn't that a 45-degree angle, or isn't it pi over 4? And there it is again, pi over 4. So we're in quadrant 4, okay? We're in quadrant 4, and the distance right there is just pi over 4, okay? And again, it's pi over 4. Whatever, radians is awesome to find the reference angle because you have that denominator, it tells you. Okay, so the reference angle is pi over 4. Okay, again, we're in quadrant 4 with this angle. The reference angle is pi over 4. Okay, all right, that's all you need to know for now. Good luck. I'm here if you need me. Peace.